We finished because we have lots of time. And this next little section is actually pretty short. Homework is pretty short itself too. So let's go ahead and learn topic 1.5. So made you think a lot with some word problems. You can relax a bit. Inequalities are very similar to regular equations. It's just that their solution represents more than just one number. So like if x is greater than 5, it's any number other than 5 to infinity, right? Or if x is less than 5, it's any number smaller than 5 to negative infinity. On and on. That number line goes on and on forever, both directions. Oops, I about wrote 8. Because I just write, I like doing 2 circles for my infinity. I'm not very good at it. Here's one little rule you have to remember with inequalities. Whenever you get your variables on one side and your numbers on the other, if you divide or multiply to get that x by itself by a negative, you have to flip your inequality symbol. Do you remember that? So that's one little thing you have to remember. This is also why when I can, I try to keep the variable on the left. It doesn't have to be, because you can mirror it and change it all if your variable's on the right with inequalities. But it just helps with reading and to really think, what does that mean? X is greater than 5, you know? So you probably remember how to do this. You may not be familiar with some of the notations. There's something called set builder notation, which is just a fancy way to write what you've been doing in the past. X is greater than 5, but they do some little extras around it. But interval notation, I'm really going to hit hard on, and you really need to know this. So maybe you've never learned about how to write it. So that's what you'll be hopefully learning today if you don't know how. So let's go solve this one. 2x plus 1 is less than 7. We're going to subtract 1 from both sides. So we have 2x is less than 6. Finishing solving, we know we just divide by 2. We're dividing by a positive number, so we don't need to flip the inequality symbol. It's simply just x is less than 3. So in WebAssign, technically, if you're ever entering it, some of these set builder notations are just going to be multiple choice, so you don't have to worry about it too much. But if you're ever entering it, you're really only entering this part. But what you're going to be entering it around is an x with a straight line. That means x such that. And over here, you're going to have x. You're going to be entering your x is less than 3, and you'll have squiggly lines already around it. So where I have red, that's already going to be there for you if you enter it in WebAssign, and you're really, I'm going to box this out. Actually, I'm just going to highlight it. You're really just entering this part. So I don't know. I feel like that's pretty not necessary, but that's what we're learning. Interval notation is necessary, though, so let's focus on that. So when we're doing interval notation, you need to always graph first, because you're going to build your interval notation from left to right from your graph. So let's just do a number line. You don't even have to do anything before or after it unless you just want. I almost always never do. I just know anything greater to the right, left. I don't need to know the numbers. The only thing I'm going to talk about is maybe in high school or in the past, when you were learning to graph, did you use a closed circle on your graph or an open circle? So we're not using that. We're going to learn something new, but it goes with our interval notation, so it's going to be an easy thing to transition to. Okay? So when we use closed, that was when we were saying it was or equal to. It was less than or equal to, greater than or equal to. The closed circle said I'm including this number and anything on. So when you were doing it, it made a lot of sense. Well, now you're going to use hard brackets. Okay? I just call them hard brackets. Open circle, it was just the less than or greater than symbol. Because what we were saying when we did the circle was starting here but not including this number. Anything to the right or left could be a solution. So in that case, we're using soft brackets. So if you like to kind of have that extra note up there, That's going to help you transition a little bit, but we're using the hard and open brackets when we're writing interval notation, so that's how we need to graph it in WebAssign. You will have to graph some of them, just by the way. So if I said x is less than 3, which way is my arrow pointing? To the left or to the right? Left. So I know we're going this way. I'm going to do it with red just to kind of help. And if it's less than, you're going to put in a soft bracket, because it's not or equal to, at 3. And it's going on and on and on to negative infinity. So the reason why we just take, literally, when you do it, it's going to be way faster, like a second, is because we're using this to build our interval notation. You're always going to put a soft bracket by infinity because we can never attain infinity, right? That's not attainable. We can't ever include that number. It's not really a number itself. And then you're going to put a comment and you're going to put your 3. And since we have a soft bracket up here, we know we have a soft bracket right here. If it was an or equal to symbol, you would have put a hard bracket up here. So you would have put a hard bracket right here too. So if you'd never learned about interval notation, that's what we're trying to get you to learn today. Let's do another one. So let's solve this one. We would add 2 to both sides, right? So negative 3x is less than or equal to 12. Solving for x, we would divide by negative. Because we're dividing by negative, what do we have to do? Flip the symbol. So I'm going to circle it. I like to do this little loopity-loop. So I'm telling myself this is what I did. I have x is now greater than or equal to, and to flip that symbol, a negative 4. So, our set builder notation is really not, you're just going to be entering this in or looking for the x and the straight line with this written x. X is greater than or equal to negative 4, and then your little squigglies, brackets. They will already be there. I should have done that in red. But again, like I said, a lot of times when you're looking at interval notation, you are going to see that as multiple choice. Written work for me, when you're taking a quiz or a test, I ask you for interval notation. I don't really ask you for a set builder notation anyways. Okay, so just know what that looks like so you're not shocked when you look at WebAssign.
So why did we flip the sign?
So when working with inequalities, it's just like a stated rule. If you divide by a negative number, then we're required to flip the symbol. Okay. Kind of comes back to that mirroring thing. It's kind of like x would have been red on the right, and so if you mirrored it, but that's getting into too much detail. So if we could just remember that rule, maybe. If this was a negative fraction and you had to multiply, remember you flip it and you had to multiply with a negative, so you still have to flip the symbol, right? Don't forget that. It stays with it. Okay, so interval notation, let's just do a number line. We have negative 4. Am I using a hard or a soft bracket on this one?
Soft. Dang it.
I know. I mean, it was 50-50, so just throw one out. It's good. It's a hard bracket because if we're saying or equal to, then the hard bracket is kind of like a way of saying we're including this number. It's a hard line through, I guess. I don't really know. And am I pointing to the right or to the left if it's greater than negative 4?
Right.
To the right. If you guys are reading them left to right and you have your variable on the left, this tells you your direction of your line. It's pointing to the right for you, right? Just a memory device that helps. Okay. So, and I said I'm doing a hard bracket because of the or equal to. So this is where you need to use that hard bracket. Okay, and it's going on to positive infinity. So again, this is what you're using in your interval notation. Since there's a hard bracket by 4, we're going to put that before. So we read them left to right. So since that's coming first this time, we put -4, comma, to infinity. And we always have soft brackets by infinity because we cannot attain infinity. So showing you both of those at once, just to kind of show you why doing the number line. I mean, I'm not like, if you just have to answer something in interval notation and I don't tell you to graph it, sometimes they don't. You need to know to graph it because it makes it really easy to set it up and read from left to right what goes where in your interval notation. Because sometimes people get it mixed up. Like, how do you know what comes first? You read it left to right. So when you're looking at this, once you understand interval notation, you should know that means anything from negative infinity up to, but not including 3, could be a solution. 2.9. You know, any number could be. This one would be like including -4 and anything bigger, maybe like 1,000, could be a solution, right? So that's the basics of that. When you're working with WebAssign to create the line, you will choose like the hard or the soft bracket at the thing, and then you'll like use a pointer to like click on the line, which direction you want it to go. So on the right side, like if you want it to go to the right, you click over here and it will draw a line for you. I think you'll figure those tools out pretty easily, but if you struggle, let me know. Last thing is compound inequalities. Sometimes we have or, actually it's not the last thing, we have absolute value inequalities. But compound inequalities, we have an and an or statement. I know it's Tuesday, Thursdays are long. Everybody take a big breath in. Breath out. We can get through today. That's for me. It's long for me to be up here talking. Okay, and or. And means like they're probably sharing some solution. Or means they go opposite directions. They don't share, and that's called a union, which we'll talk about now. So we're going to do an or inequality. Okay, so the or inequality, you just go solve, right? We have divide by 2, so x is less than 5. Over here we're subtracting 1. We have x is greater than 8. Zoom in a little bit so you can see that a little better. So before I jump into trying to write this into set builder notation or interval notation, just because what if we forget, does and or, which one is this? Or am I sharing solutions with an or statement, or am I not? So on a number line, we'd have 5 somewhere over here and 8 somewhere over there. And if we just graph it, we can tell if they share solutions or not real quickly. So I'm using a soft bracket at 5, and it says x is less than 5. And this is going to help with your interval notation, so you need to do it anyways. You need to draw the graph anyways. And if x is greater than 8, soft bracket because we're not including it, and that's going anywhere to the right to positive infinity. So since arrows point in opposite directions, this is called a union. And that's not the letter U on your keyboard. There is a tool in WebAssign. Use that tool. Because I'm pretty sure if you type a U, it's going to say there's a syntax error or something maybe. Because it's not going to know how to read that. So that's just called a union. So we're actually having 2 interval notations. So I'm going to go to interval notation first. We're working with interval notation mostly anyways. So going to it first, and I'll show you set builder. So we read left to right, and we have to have our union in between the 2. So we have a soft bracket, negative infinity, comma 5, and we said there was a soft bracket for that. That tells us we're not including 5. We have our union, so it's a U, it's not a V, but I don't put a little tail on it. And then we have a soft bracket 8, 2, so comma, positive infinity. So if you have infinities in a union, they should be on the outsides, just like you see it on the number line. So when we're talking about set builder notation and you're talking about compound inequalities, the proper way to write compound inequalities is to have an x with a value before and after and always using less than symbols. If it's an or statement, you can't do that. There has to be two sentences because they don't share. That x isn't sharing, right? They don't share anything in the middle, so we can't do an or. So when you do set builder notation, these will be, by the way, multiple choice. I know these are. You just have to pick the right one. These will be written something like this. There's a couple ways to write it, but I think it looks like this and with a sign. So you have your squiggly and your x and your line. And we'll have an x is less than 5 or x is greater than 8. So when I say two sentences, you have to use both of those in there, or you'll see both of them in there. So or statements are two sentences. When we do this and, we can write one sentence with x in between the two values. So we'll go over that with set builder notation, but it's mostly going over how to write it. Okay, so let's go solve. See if pencil's stopping, so it's kind of trying to pause, but it looks like everybody's done. So we divide by 4. So x is greater than -2. We're going to subtract 1 from both sides. So I have a -2x is greater than -6. Maybe put a star by it. This is that rule. If you divide by a -2 or a negative number, you have to flip your inequality symbol because of dividing by a negative. So we have x is less than a +3. So my next step always is to just go to a number line. Am I using hard or soft brackets on both of these? Soft. I just went ahead and said both of them since they're both the same. If they were or equal to, remember you'd have to use a hard bracket. We've had soft. If x is greater than -2, it's pointing to the right. We know we're going towards 3. I'm not going to go past it because I see over here x is less than 3. So they stop each other, right? They land into each other, and anything in between here, all those numbers in between -2 and 3, they share. So when writing interval notation, do you see any of that going to infinity? No, you still just read it just like that. We just it kind of looks like an ordered pair, but when you're talking about interval notation of a number, it doesn't mean the same thing as an ordered pair. It means from -2, but not including it, to 3, but not including, would be the set of numbers that could satisfy that inequality. Now going to set builder notation, what I want you to focus on the most, so let's do our squiggly and our X and our line. What I want you to focus on the most is this line right here. I'm going to put an X, and we should always have less than symbols. It's always read less than with the X in between. So if you look up here, you can kind of decide, you should always have the smallest to the greatest numbers. So -2 and 3. Least to greatest, using less than symbols. But let's go see if that's really what those means. If we pull this apart, X is less than 3, that's true, right? That's what we said up here. Up here, X is greater than -2. Is this mirrored? Do you get what I mean by mirrored? They're opposite signs with a flip symbol. So if -2 is less than X, that's the same thing as saying X is greater than -2. So that's what one sentence means. And you can do that when you are working with an and inequality. Again, I will tell you, I'm not real picky about writing them as one sentence, two sentence. You just need to be able to understand that for WebAssign. I'm probably going to grade it either way when you're doing your written work. You can just answer it pretty happy because I want to see this interval notation. Okay, last thing. We got 10 minutes. Let's all stay tuned. Let's power through what we know already about inequalities and what we learned about absolute value. They just had a baby. Okay? We're putting them together. So just like when we're talking about absolute value equations, we cannot equal or be less than or greater than a negative number. Not possible. Same thing, just like equations, you need to have your absolute value isolated. Both of these are that way. We can just work with them. I'm not going to try to throw you anything weird anyways, but remember it applies to both things. The only thing that we do need to know is we do have two equations. So for the second one, when you change the sign, you need to also change the inequality symbol. Okay? Oh, well, that's the rule, but we need to also change the inequality symbol and sign. Should just say, let's just wiggle that out from what I'm saying. So we have, let's write our two equations. 2x plus 5 is greater than 3. And this is what I'm trying to tell you. When we change the sign of that number on the right, when we say we have 2x plus 5, we have a negative 3, you have to change that to a less than symbol, and it's negative. And then all the other rules would apply. If you were dividing by a negative, you'd have to flip it again. But now let's just go solve. So let's subtract 5 from both sides. So I have 2 is greater than a negative, 2x, sorry, is greater than a negative 2. Am I dividing by a negative number to get x by itself? I'm not, right? 2 divided by 2 here is positive, so we're not flipping that symbol. So we get x is greater than negative 1. Okay, let's come over here. We're subtracting 5 from both sides. When we get to the right-hand side, you actually ended up adding, right? Because they're both negative. Add, it becomes negative 8. Solving, we're dividing by a positive number, so we're not flipping a symbol. We're saying x is less than negative 4. And I am just going to write my answer in interval notation. That's the only instruction. Solve and write your answer in interval notation. So, which number is to the left?
-4.
Right, negative 4. Think about your number line. It's a little bit backwards, right? Because 0 is over here, remember? And then we start counting up. So we're using a soft bracket. So x is greater than negative 1. So here we have that, greater than negative 1 going on to positive infinity. X is less than negative 4. So that would go to the left to negative infinity. What do I put in the middle when writing this? Union. So since they don't share solutions, we say soft bracket negative infinity comma 4, union soft bracket negative 1 comma infinity soft bracket. The next example is literally, just so that we've done two of them together, so you see that you're going to do the same thing. It's a different equation, but we have absolute value brackets. Over here on this other side of the inequality, it's positive, so we can work with this, right? So we're going to say 5 minus 2x is less than 7. What do I do to my second one, or my second equation? The left stays the same. I flip my symbol, so it was less than, it needs to be greater than, and I call that a -7 now. So in red, hopefully you'll see, that's what I did up here. I changed my inequality symbol and sign. So we subtract 5 from both sides. So we say -2x is less than 2. I'm going to have to divide by -2. What do I have to do with my symbol? Because I'm dividing by negative.
Flip it.
Let's flip it. So x is less than, or no, I just pulled the same thing down, didn't I? X is greater than, it was less than, it should be greater than, a -1. Almost there. We got those, guys. So let's subtract 5. So we have -2x is greater than a -12. As that same step as our second step, if we're dividing by -2, we're having to flip that symbol. So we have x is less than a +6. So on a number line, if I had -1 and 6, all of these have been soft brackets. Just know in your homework you will see some hard brackets. So if x is greater than -1, we're saying soft bracket point towards 6. And if x is less than 6, soft bracket point towards -1. So we're sharing the middle. We don't have a union, right? So we would just say, to answer that in interval notation, soft bracket, comma, 6, soft bracket. So thinking back to what we did before, would this one be an and or an or statement if it was written in a different way? If they don't share, that would be an or. If they do share, that would have been an and. Okay, so we have 3 minutes left. We did it. Congratulations.